All right, welcome back to Chapter 4. Staying in Chapter 3 today, we're going to talk about what's called Cramer's Rule. So, before we begin today, we're going to start with this systems of equations that you guys have seen before. This is like what we worked with in Chapter 3. You guys would use substitution or elimination to solve this, and going from there, you would tell me where those two lines intercross. Cramer's rule is going to give us another way to do that, just another tool in our toolbox that we can do. But in order to do that, we need to make what's called a coefficient matrix. So, if I have this linear system here, my coefficient matrix, since I have a system with two variables, two equations, two variables, my coefficient matrix is going to go 3 and a negative 4 and a 2 and a 3, just like this. Notice, I put all of my x values in one column, all of my y values in the other. So notice that that 4 becomes negative since I'm subtracting it. That way we keep that sign there. So that's really all there is to setting up a coefficient matrix. Just take the numbers in front of x and y and put them in a matrix. So again, just some different practice. Coefficient matrix with a linear system, ax plus by is equal to e, and cx plus dy is equal to f. Same idea here. We're going to put the coefficient matrix down here, and we're going to take the numbers in front of the x's, a and c, and the numbers in front of y's, b and d. The reason we do this is, I know it seems a little weird to just do this with letters instead of our numbers. We're normally going to have numbers there for our coefficients, but the reason I want to do that is so that I can look here, and I've got my coefficient matrix of ax plus by is equal to e, cx plus dy is equal to f. So I've still got that same coefficient matrix. That's why I wanted to go through that so that we can understand this. And we've got AC and BD. There's my coefficient matrix. Cramer's rule for a 2x2 system. So 2 equations, 2 variables, says that as long as this determinant of A, which is going to be my coefficient matrix, so label that as A. So I can find the determinant of that just by doing the method that we learned in the last video. Then what we do is we're solving for x. So we're going to take out our x values, and instead we're going to plug in what the equation is equal to. And notice that this column right here remains unchanged. So it's exactly the way it is. Then those bars mean that we find the determinant of that, and that will spit out x for us. Again, we go back to our matrix A. Our x's now, if we're going to find the y, our x's stay the same, so I keep my x coefficients, A and C, in there. And then I'm going to take E and F and plug it in where our y's would go. So you want to replace that. So A and C stay there. And again, our determinant of A stays the same as long as it's not 0. We can use Cramer's rule because, as you guys should all know, you can't divide by 0. That bar in separating those two determinants is just a regular division or a fraction bar. So I know that seems really weird, really out there right now. So let's take a look at a problem and hopefully solidify that a little bit for us. So if we're going to use Cramer's rule to solve the system, first thing you need to do when you're using Cramer's rule, set up your coefficient matrix A. So, set up my coefficient matrix. My coefficients of x, 8 and 2. My coefficients of y, 5, and negative 4. Now, it might be useful for us to calculate the determinant of A right away. So I'm going to take 8 times 4, 8 times negative 4, plus, not plus, minus 2 times 5, which is going to give me negative 32 minus 10, or negative 42. Okay. Now that we've got that determinant, we know we're going to use that later on, so that's just nice to calculate early on so that we have that. Next thing we're going to do, we need to find our x value. So x is going to equal, I'm looking for my x value, so I'm going to replace my x values from A, this 8 and 2. What am I going to replace those with? Well, 2 and negative 10 are going to go in there. Positive 2 and negative 10. And other than that, I plug in my y values, so 5 and negative 4, and that's still divided by that negative 42. Calculate that determinant. I'm going to get 2 times negative 4 minus negative 10 times 5, all divided by negative 42. 2 times negative 4 is going to give me negative 8 minus a negative 50 is going to give me a positive 42 divided by a negative 42, which will simplify to negative 1. So that's what x is equal to. X equals negative 1. Now we're going to go through the exact same process, but we're going to do it with y now. So I'm looking for y. I'm going to leave the x values of my A matrix alone, so I'm going to have 8 and 2 here. Take out the y values, 5 and negative 4, replace them with 2 and negative 10, all over negative 42. That determinant of A that we calculated earlier. And now we calculate that determinant up top, 8 times negative 10 minus 2 times 2, all over negative 42. Simplify that numerator. I get that I have negative 84 over negative 42, which is just a positive 2. So y is 2. Since we're solving systems of equations, these guys up here look just like what we were doing in chapter 3. Then we're going to write those as an ordered pair. So yes, now I do want you to pay attention to that. So I'm going to have negative 1, 2, and that's my final answer. All right, that's it for today. Hope you enjoyed watching, and we will see you in class.